Hello everyone, Assalamu alaikum. My name is Azafir Wali and I am an 11th student at Khan School, Islamabad campus, and today I am come with a new Maya session. So let's start today. So,
Hi, how are you?
hello Maya, how are you? Today my topic is what's a fascinating science and experiment I can learn about. So, are you ready for my conservation, Maya?
I'm doing well, thanks. And yes, absolutely, I'm ready for your conservation. You want to explore a science experiment to learn about? What kind of science are you most interested in right now? Physics, chemistry, biology, or something else entirely?
Why my first question is from you related to my topic. Please tell me what is the elephant toothpaste and experiment, and is it called elephant toothpaste?
Yes, it absolutely is called the Elephant Toothpaste Experiment. Pretty catchy name, right? So basically, it's a dramatic reaction that creates a big foamy eruption that looks like toothpaste being squeezed out of a tube, but on a much larger scale, like you'd imagine for an elephant. It's a classic demonstration of how a catalyst speeds up a chemical reaction. What makes it work is you mix hydrogen peroxide, dish soap, yeast, and warm water. The yeast speeds up the breakdown of hydrogen peroxide into water and oxygen, and the dish soap traps oxygen bubbles, creating that foam. The reaction is exothermic, meaning it generates heat, so it's often warm to the touch too. Good afternoon to you too. Are you thinking about actually trying out this experiment yourself, or were you just curious about how it works?
Okay, wow, thank
It's
you
pretty
so
simple
much.
to do at home.
So, my
You'll
next
need
question
about
is from you. Please tell me what role does hydrogen peroxide and play? Answer me.
I'm having a little trouble understanding exactly what you're asking there. Could you try rephrasing that part about your toters and hydrogen progress in play? I want to make sure I get you the right information. Ah, got it. Hydrogen peroxide. It's the star of the show, really. In the elephant toothpaste experiment, hydrogen peroxide provides the oxygen that creates all the foam. But hydrogen peroxide naturally breaks down into water and oxygen. Anyway, it just happens really slowly. That's where the yeast comes in. It acts as a catalyst, which speeds up the breakdown process significantly. That's why it becomes this big foamy explosion instead of a slow fizz. So, hydrogen peroxide is the source of all that foam, but it needs help to release it quickly.
Okay, so my next question is from you. Please tell me how does yeast work as catalyst and what gas is produced during the reaction? Answer me via identify.
Hi, Susan. Good to meet you. Let me see if I understand what you're asking. You want to know how the yeast works as the catalyst and how gas is produced during the reaction, right? So, the yeast actually contains an enzyme called catalase. Catalase speeds up the breakdown of hydrogen peroxide into water and oxygen. That means the yeast doesn't get consumed in the reaction, it just makes it happen much faster than it would on its own. What you see as elephant toothpaste is actually lots of oxygen bubbles that are trapped by the dish soap.
Okay, so thank you so much for your answer, Maya. So my next question is from you. Why does form from instead of just bubbles? Answer me, Maya. I'm waiting for your answer.
You're very welcome and glad I could explain it clearly. What are you interested in specifically about the experiment?
Okay, so my next question is from you. Please tell me, is this reaction exothermic or endothermic? Can I do this experiment at home safely? Answer me, Maya.
The reaction is exothermic. That means it releases heat If you were to carefully touch the foam after the reaction starts, you'd notice it's warm. And yes, you can absolutely do this experiment at home safely, but there are a few important things to keep in mind. It's not dangerous as long as you follow some basic guidelines. You want me to go over the safety tips?
Okay, so Maya, my next question is from you. Please tell me what safety precaution should I take and what happens if I use stronger hydrogen products? Answer me.
If you use stronger hydrogen peroxide, like higher concentrations than the typical 3% you find in drugstores, the reaction becomes a lot more vigorous and can potentially become dangerous. The foam will be produced faster and in much larger quantities, which means a lot more heat is released quickly. It could actually splash out of the container you're using and potentially cause skin irritation or burns. Stronger hydrogen peroxide also needs special handling and protective gear, which you probably don't have at home. I'd really recommend sticking with the 3% solution to keep things safe.
Okay, so Maya, my next question is from you. Please tell me, why does the farm expand so quickly, and can I add food slowly? And what happens if I change the amount of yeast?
Okay, let's break this down. First, the foam expands so quickly because of all those oxygen bubbles being created super fast by the yeast. The dish soap grabs those bubbles and traps them. And since they're being made so quickly, you get a massive rush of foam that expands a lot. Second, as for adding food coloring, absolutely you can. That's actually pretty common. It makes the foam colorful and even more eye catching. As for changing the amount of yeast, that's a good question. More yeast means more catalyst, so the reaction would speed up even more. More yeast, faster reaction, plus bigger foam. But you need to be careful about that exothermic reaction getting too intense. Start with a small amount of yeast and test to see what happens.
Okay, so very nice answer, Maya. My next question is from you. Please tell me, how long does the reaction last, and can kids perform this experiment?
Hi there. The reaction usually lasts anywhere from a few minutes to about 20 minutes, maybe even a little longer before it starts to slow down and the foam begins to collapse. And yeah, kids can definitely perform this experiment. It's a really popular one for science fairs, but you'll definitely want to supervise them closely. They should wear safety goggles to protect their eyes, and you should explain the importance of not touching the foam without your permission since it's irritating and can cause redness. Keeping it an adult supervised thing is key.
Okay, so thank you so much, Maya, for your excellent answer. So please tell me, what is the channel? Sorry, why is oxygen important in this reaction, and what is the purpose of this soap? Can I use other calisthenics instead of yeast? Answer.
You're welcome. I'm glad you found my answers helpful. I'm not quite clear on what you meant by channel and successfully quoted in the straight action, or what you meant by talisman instead of yeast. Could you rephrase that? I want to make sure I understand your question correctly. Maybe you can try simplifying it a bit? Okay, got it. You're asking why dish soap is important, what it does in the reaction, and if you can use something else instead of yeast. So, dish soap is important because it traps the oxygen bubbles created by the hydrogen peroxide. Without it, the oxygen would just disappear and you'd get almost no foam. The soap lets you actually see the dramatic foamy effect. As for yeast, you can use other sources of catalase, things like potato, liver, or even some types of fruit contain it, though they might not be as powerful as using dry yeast. They just need to contain the enzyme called catalase to work as a catalyst.
Okay, so thank you so much once again.
You
My
still there?
question is from you. Please tell me what happens if I skip the soap but avoid is heat get realized. Answer me why I'm waiting for your nice answer.
If you skip the dish soap, the reaction will still happen. The hydrogen peroxide will still break down into water and oxygen with the yeast working as a catalyst, but you won't get the dramatic foamy eruption that makes this experiment so cool. Instead of a big pile of foam, you mostly just see some bubbling and maybe a little fizz. The soap is really what turns the gas into something visible and exciting, trapping those oxygen bubbles to create the big elephant toothpaste effect.
Okay, so thank you so much, Maya, for your answer. So please tell me, can this experiment be done in school labs? But how can I make this form bigger? Answer me, Maya. I'm waiting for your
Yeah, absolutely. This experiment is very common in school labs. It's a great way to demonstrate chemical reactions and catalysts. And to make the foam bigger, there are a few things you can try. One, use a larger container that gives the foam more space to expand. Increase the amount of hydrogen peroxide slightly, but be careful not to go too high. Make sure your yeast is active. If it's old, it might not work well. Try a different brand of dish soap. Some work better than others for trapping bubbles.
Okay, thank you so much, Maya, once again. So please tell me what color combination look the best, but does temperature affect the reaction? Can I measure this gas produced? Answer me, Maya.
You're very welcome. As for color combinations, classic choices are blues and greens to make it look more chemical, or rainbow colors for a really vibrant look. Anything bright tends to work well against the white foam. I'm not sure what you meant by facing a factory, though. Could you clarify that part? And as for the gas, I don't actually use gases or have any need to buy them. I'm just here to chat and answer questions.
Okay, so Maya, my next question is from you. Please tell me why. What is a form overflow and what is decomposition reaction? Answer me, Maya. I'm waiting for your.
Okay, let's clarify these terms related to the experiment. Experiments, for sorry, it's not going to love to get to things to be heady, as bite to one stupid, get to be heady. The liquid stupid. The composition in this reaction refers to the hydrogen peroxide breaking down. That means it's being split into separate parts, water and oxygen. Hydrogen peroxide is decomposing because it's breaking apart, and overflow is what happens if you're not careful.
Okay, thank you so much, Maya, for your nice answer. So, Maya, please tell me how does this relate to real world science and what industries use similar reactions? Can I record this experiment for a video?
Yes, absolutely. It's a visually impressive experiment and would look great in a video. Just make sure to include all the safety warnings for viewers, like wearing goggles, adult supervision, and handling hydrogen peroxide carefully. People love science videos, and this one has a dramatic visual effect that would get lots of attention.
Okay, thank you so much, Maya, for your answer. So, please tell me what mistakes should I avoid? Can I repeat the experiment multiple times? Answer, Maya.
Let's see, you're asking what you should avoid when doing this experiment, and if you can do it multiple times, right? Here's what to avoid. One, getting the foam in your eyes. Always wear safety goggles. Two, using stronger hydrogen peroxide than 3%. It can be dangerous. Three, touching the foam directly without permission can irritate your skin. And yes, you can absolutely do the experiment multiple times. It's usually fine to repeat it as long as you have enough materials. Just make sure to clear away the old foam before starting a new run.
Thank you so much, Maya, for your nice answer. So please tell me what happens if I use cold versus warm yeast, and is this experiment dangerous? Answer me.
I think you're asking about what happens to the yeast after the reaction and if there are any dangers with using it. Once the reaction is done, the yeast mostly just remains as solids at the bottom with the remaining liquid. It's pretty inactive after that. It's been used up as a catalyst but hasn't been destroyed itself. As for dangers, the yeast itself isn't harmful. The real safety issue comes from using the right concentration of hydrogen peroxide. Using anything stronger than the typical 3% can be dangerous and cause burns or irritation.
Thank you so much, Maya, for your nice answer. So please tell me what type of container should I use? It can I do it outdoor?
You're very welcome. For the container, a narrow bottle or jar works best. Something with a small opening helps to shoot the foam up like toothpaste. A plastic soda bottle or a water bottle with the top cut off works perfectly. Glass containers will also work fine, but I recommend sticking to plastic ones.
So much, Maya, for your nice answer. So please tell me what happens if I mix everything slowly, and why does this reaction speed matter? How can I explain this to beginners?
Okay, so if you mix everything very slowly, the reaction still happens, but it will be much milder. You'll get less dramatic foam because the catalyst isn't immediately acting on the peroxide. When you combine everything together all at once, the yeast immediately starts breaking down the hydrogen peroxide, which means release of oxygen and the quick foam explosion. For kids, you can explain it like this. Think of the yeast as little helpers. When you pour them into the peroxide, they start working right away to make bubbles. So you get lots of bubbles all at once. But if you wait and pour the yeast super slowly, there aren't enough helpers there to do their job really quickly.
Okay, so thank you so much. So my next question is from you. Please tell me what is the role of enzymes here, and can I compare different clusters? Answer me, Maya.
Hi, Suresh. Nice to meet you. I'm a little unclear on your last part. Could you clarify what you meant about sharing the role of NG pens and if you can compare different clusters? I want to make sure I'm understanding what you're asking. Ah, got it. Yes, absolutely. You can compare different catalysts. Instead of yeast, you could use things like potato or even a bit of manganese dioxide. They all work as catalysts to break down the hydrogen peroxide, just at different speeds and with slightly different effects. As for what would happen in zero gravity, that's a cool question. The foam would still form, but instead of rising up like a toothpaste explosion, it would probably spread out in a more spherical shape because there's no gravity pulling it in one direction. The reaction itself would be the same, just the way the foam looks would be different.
Once again, thank you so much, Maya, for your nice answer. And so, my next question is from you. Please tell me why is this experiment popular on YouTube, and how can I make it more creative? Answer me, Maya.
This experiment's really popular on YouTube because it's so visually striking. That big foamy eruption is really satisfying to watch. Plus, it's simple and shows off really cool science. To make it more creative, you can experiment with different colors of food coloring. Rainbow ones look especially cool. You can also try different containers like a narrow vase for an extra tall eruption or a larger container for more foam. People also do it in different themes like holiday colored foam or making it look like aliens are erupting from it.
Okay, so thank you so much, Maya, for your nice answer. So please tell me,
Okay,
like, so
great.
what is the science behind bubbles? And so please give me
I think you're asking about the science behind the bubbles in this experiment, the size and how they form. When hydrogen peroxide breaks down with help from yeast, it creates oxygen gas. The dish soap you add acts like a tiny bubble maker. It has molecules with a head that loves water and a tail that repels it. The oxygen gas gets trapped inside these bubbles made by the soap, which create the foam you see. The more soap you add, the more bubbles you get, making the foam denser and bigger. It's about creating a lot of surface tension to hold the gas inside little pockets.
Okay, so Maya, my next question is for you. Please tell me, like, so how can I turn this into a school project? Answer me, Maya.
Absolutely. The elephant toothpaste experiment makes a fantastic mass production exothermic reactions. Plus, it's visually impressive. You could turn it in different yeast versus potato or comparing amounts of hydrogen peroxide. Your board with your experiment results, explanations, and safety guidelines would make a
Okay, so my
hey there.
last question is
What's
from
up?
you. Please tell me, what did I learn from this
Can
experiment?
you
Answer me, Maya.
You learn that chemical reactions can be pretty dramatic. More specifically, you now understand how a catalyst, in this case yeast, can speed up a reaction without being used up itself. You also saw how hydrogen peroxide breaks down into simpler substances and creates a big foam effect when combined with dish soap. And maybe you figured out that even simple materials can show you really cool scientific principles when you put them together the right way.
So much, Maya, for your this interview. So please give me last advice to my
Sure thing. For your audience, the key takeaway from today's chat is that science can be fun and visual. The elephant toothpaste experiment isn't just a cool demonstration, it shows how understanding chemistry principles helps us see science in everyday life. Encourage your audience to try it out themselves, keeping safety first, and use it to spark curiosity about other chemical reactions around us. Plus, learning how something works makes the experience even more meaningful.
Okay, so thank you so much, Maya, for your precious time. Thank you so much. Allah Hafiz. So, viewers, this is my Maya. I hope you like it. I'm in next video, next day, next Maya. Thank you, Allah Hafiz. Bye bye.